Hey boys and girls, how's everything today? Let's go over a simple thing, hopefully quickly, that there are a lot of people that don't understand. If you understand all this, then this is apparently not for you. But there's so many questions asked about their work offsets. People confuse home position with their work offset zero position and things like that. So I just want you to understand, any home position doesn't really mean much. It doesn't do anything for you or your project. You don't need to worry about home position. You can home like I can home the machine right now. Assuming you can see my screen right here in G Center, if you push home, and it will home the machine. And the only main reason you might do that, it's best to home a machine when you first start it. It's not necessarily important, but on this one it can just kind of square the Y up, or the X gantry to make sure it's straight, because it has two homing switches back there. Homing switches are not super accurate, so don't plan on them being exactly, and I've proved that. And if you think they are, go check with your Auto Zero touch plate in the front left corner of your table. And I know I've written my numbers down. I've verified many times that sometimes they're really close, sometimes they're not very close. So if you want to verify something, that's not what this video is about. I'm sorry I get off track like that. But you would be better off to set your zero at the front left corner of your machine and then set your workpiece in there. If you're going to come back and have to repeat something, if you're going to have to do that, you need to find a way. You can always find your position even after you shut your machine off. And don't trust necessarily your home position, because it's not always accurate. I've seen it to be off 15 or 20 thousandths many times, and that's just it's just how it is. So that's not what this is about. Let's go in, and I'm just going to mill off a little bit off this top 120 thousandths of an inch. I'm just fitting this under the table because I've got a keyboard mount. This is not important for this, but I just want to show you I'm mounting this keyboard mount under here. I just need a good place to mount it, and then it can slide up out of the way. Keyboard and mouse can go in here, and that's what this is about. Nothing much. It's just a piece of wood I had. It's got a slot in the back. It came off a crate at work or something I found, and I just need to take a little bit off so that I can bolt it up under here pretty flush with the bottom under there. So now there's two different ways that I've drawn up to do this, and the main reason I want to do this is I want you to understand how your machine moves, how your work offsets work, how you can know without any doubt where your machine's going to be moving. Because see, we got clamps here in the way, and I don't often use clamps, but I put these on mainly just to prove a point here on this of how you can know. Now I know you can't see real close over here. I'm sorry, the camera's right behind the monitor there. I just took a square and I lined up and I put a line knowing I gave myself about 1/4 of an inch or better, so that I know when I use this face mill here, I was going to use this 2-inch face mill to go on this 1.5-inch wide wood. So I know all I got to do is travel down the center line of that roughly, and I've got plenty of room for error. It's not that critical. But I took a square and I put a line, and I know where that is. I've measured that. If I move 38 inches, I have more than enough room. I drew me a little X or crosshair right there where I'm going to center that. Now, let's quickly look in Vectric software, Aspire, VCarve Pro, whatever you use. You could use other softwares, it doesn't matter. But so if I open that here, I'll just show you. I just drew a vector here because I want to come in at my line that I'm coming in. I'm going to come in, and I'm going to go down, and then I'm going to come out. See that line there? And then I'm going to drop it down another 40 thousandths. I'm going to do 3 passes. I'm taking 40 thousandths per pass, And that's all that's going to do. You can do that in Vectric. And if you can notice, I've got a toolpath here, and that's all it's going to do. So you can program that. You know, I programmed this with the tool that was in a 1/8 end mill, because we're going on the line here. 3 passes. I went in and edited the tool right here. Every time you run, you should edit your tool for the job you're working on, and just look. And I wouldn't run that big cutter more than 10,000. I'm actually probably going to only run it about 9,000. 80 inches a minute is fairly quick for me on that. I don't know how well that's a big cutter, 2 inches. It takes a lot of load. But anyway, that's how I did that, and that's all there is to that. And then save the program. So, but better than that, you know, I know that I can go in and I can simulate this a little bit. It's kind of hard to simulate something so skinny like that, but if you previewed that, it's just going to go in and do that. And since I used that little tool, it's just going to show that it cut a line. But anyway, all I did was just cut along the center line and come out. And you know, if you hover over that, you can see that you went 120. If you look down here in the bottom area down here, anytime you hover over your cut, it'll show what you cut down to Z minus 0.12, 120, 120 thousandths right there. It's about 1/8 of an inch. It's 3 millimeters roughly. Okay. Now, you can do it that way, but do you really need to waste time and do that? And do you really know, without looking at that G-code, where your tool really is going? And also, let me remind you that when you go in here, we don't want to be coming in here on our 0 necessarily, because we may get close to crashing in here. So if you go in here to where it says set, you can park this tool, get it to begin and end wherever you want it to, and make sure your Z is coming up to the height that you want it to be. But that's just going above your material. So as long as these are positive numbers, you should be fine. And also, you got to be watching for your dust collection boots or anything like this that's, you know, that may interfere with hitting clamps. That's another reason I don't like using clamps, because a lot of times you can't use your dust collection because they'll hit. But you can go into this and set this like -6 on the X. I just started here and somewhere at 3 inches up here. Just make sure you're parking this or getting it to begin and end somewhere away from your clamps, because I think I programmed this. As you can see, my XY0 is down here on this at the corner of my wood, and so if you can see, that would have crashed if I'd come down here. So that's why I want to start over here, move here, do the work. But let's go look at a different method that I think is very useful for you to learn. And don't be afraid to learn what the G-code looks like. There's so much to be learned by looking at that G-code. And if you go in here, and a lot of times if you're running your machine in inches, well, we won't get sidetracked right now. I'm not going to do that. So anyway, for now, let's go look at, now I created a a G-code by hand. And if you would like a copy of something like this, holler at me anytime. I'll be glad to email you this. You can look at it, refer to it anytime you want, so you can understand the moves are so simple. I believe a first or second grader could understand it very easily. So let's just open the file. I've already typed it up, and it didn't take me just a few minutes. It took longer because I described a lot of it, and I want you to be able to understand it. So if I go to oh my gosh, you know, when you're trying to find something, there we go. So here it is. Now I put everything on here so you can see it, and let me get this. I want to make sure that none of this is being blocked out by anything. I don't think it is. I don't know. Hopefully you can see this without any trouble here. So I wish I knew how to know that for sure. Let's open this. Maybe that works. Okay. Sorry I'm so goofy. I don't know how this thing works too much, but let's just close this out of the way for the moment. So hopefully you can see this G code here, and all it is the first line that I write is a G0, G20, G17, G90, G20, and you can put G54 if you want or not. That's just your work offset. And that number, let me show you right quick where that comes from, is whatever you've got selected in here in G-Sender or whatever you're using. See that workspace? It says G54, and don't be selecting any of these other ones and messing with that unless you really know what you're doing. It's very uncommon to use any of the other ones. But I like to call it G54 because that's what I always use, and if I don't, I can go in there and change that anytime. So, but first off, let's set our 0 so you'll understand the code that we're talking about. And actually, I may have already set it, so let's move this to X, Y. Okay. Now, I haven't changed tools yet, but I just moved this to that little X because I'm going to be using the center line of this board as my X and Y 0 right there in the center at this spot that I've told you was safe. That's going to be safe, so we're not going to hit or clamp when we come in and out or anything. So that's where I've set it, and you can see I have zeros called up here on my X and my Y. I've already pushed that X and Y 0. See there? And I haven't set the Z yet because I haven't changed tools yet. But we could do that right quick, and let's just see. You know, so many people want to do the automatic tool changing, but you know, I run industrial machines at work all the time that have automatic tool changers and lathes and mills, and it's not that I don't understand them. I use them every day. It's just not important at home to me. So yeah, I usually clean all my collets real good before I use them. This is a 1/2 inch shank. So let's just screw this on. I mean, this is just how quick you can change tools. You just get that in there. You don't have to tighten these so tight everyone that wants to do. If you'll get 2 hands, get the wrenches lined up like this and just squeeze them together pretty snug, that is really tight, and you're not pulling around on the machine. You just squeeze the wrenches, and there you go. Now we just need to set that, and I hope you can see this. It's not real critical on this. You can either spin it, or I don't feel like walking over. I usually get a piece of paper and I'll find it. This ain't necessarily flat anyway everywhere, but the best way on something that don't matter that much on this is I'm not real worried about the thickness we end up with. And get this down close, and then watch your numbers here. Make sure your Z, that's going to go 50 thousandths per click. So, and I can hear it clicking, but I'm going to go back to precise, and I'm going to get it just a little bit more. This is going to go 5 thousandths per click. See, that's hitting pretty good. That's good enough. Now we'll go right here where it says Z0, and we're going to click that, and that's showing a 0. Now we're going to raise it just to get it out of the way. Get this back completely out of our way right here, and we can see if this is going to line up. I don't know if this is going to work. It doesn't look. I got this from a PW. The ones that make the spindle. I think this is version 7. So you want that to be pretty close. And it's pretty good. It's pretty close to flush with the bottom of that brush. So that should work, but we want to come up and see when this is running, is it really going to clear everything? So let's go to XY0 again. And when that comes down, over here, we're going to be in this area. So to see if it's going to clear when it's down. We're at 277, and see, I don't want that to be touching that plastic. It might break it. And we are 27 thousandths, so we need to go down to 120 is where that's going to end up. And it looks like we're minus 123, so that is going to clear right there. Let's go down there. These are things you need to for sure do every time you run. Be sure that everything's going to clear. And we know I'll tell you right now, I'm moving that 38 inches is how far I'm going with this. So let me go over here and make sure I'm not going to hit that at 38 inches. This is what I mean about knowing where your machine is going to travel during the program. So I'm looking at the DRO up there. I think you can probably see it too. That's at 34. And we're going to be moving 1 inch at a time. So let's go on the Y. It's 35, 36, 37. And we're going to go 38. And we are, the brush is hitting, but not the plastic, so I'm going to say we're safe to run that. Most of the time with clamps, you can't run your dust collection, and you can see I have that turned sideways. If I had it turned the other way, then it might not clear some stuff, so we're good on that. So that's number one thing. Make sure your work holding is right. Make sure nothing's going to move, get loose. Nothing's going to get in the way, get hit. Make sure you know where your program's going. And I'm going to show you next how to know that. I just know that it's 38 inches. That's why I did that. So let's just park this right there for a moment. Doesn't matter. I would raise the Z back up just for the heck of it. Okay. Now, I'll show you the program I wrote here, and it's really easy. So like I said, the first of the code, if you're running in inches, you need this to be like this, G20. If you're running millimeters, you want that to say G21. Just to make sure the machine knows these numbers mean inches or millimeters. You can, even if you make your program, some other way, it can still run this way. As long as you put your G21, it will think that's a Z 1 millimeter, which is about 39.5 thousandths. So, but anyway, that's G0, that just means we're in rapid mode, inches. We're doing an XY plane, that's for milling, G17. G90, absolute moves, meaning these numbers that we're looking at here on the DRO up here is exactly where it's moving from our zero that we set. That's the distance from that zero, not from home. Don't ever worry about home position. That doesn't matter. That has nothing to do with the code. Only this zero that you set up there where I showed you that G54, right up here, that's the only thing that these numbers are talking about is that's X. Right now it's minus 20 inches to the left of where we set that, right there on that, and it's 21 inches, 21.5 inches in the Y, positive direction. Positive Y is going to be away from you. Positive X is going to be to your right if you're standing in front of the machine. At least this alt mill here. There's some machines that may be a little different, but not many. All right, so now once we get the start of it, notice in parentheses, if you put something in parentheses, that's just some notes you can put in here that the machine ignores anything that's in parentheses, so you can put yourself some notes in here. And I wrote all of this just so you can see this real clearly. And what all this stuff is, I tried to line it all up out of the way so it don't look confusing. So you can ignore all of this unless you want to refer to what each line means. And it's just really simple. The Z is going to start out 1 inch above where we set the zero. Remember, all of these numbers are based on where we set the zero on the X, Y, and the Z. So it's going to start out 1 inch. That's safe. See, I put raise Z to safety. That's because that means it's above any of this. It's not going to crash into nothing. If it happened to be over there moving somewhere, across the table before it gets to its start point, make sure you know where all that stuff is, and that this number at the first part of your code is going to clear any of that stuff. And you can set that in your Vectric software as well in that place I showed you earlier. And then the next move to start position is going to go to X minus 2 inches and Y 0. So it's going to be right on where we're going to start. And that's what I said, move to start position. We're going to turn the spindle on. I'm just running 9,000 RPMs. That's a big cutter, and you don't really want to use big cutters at a high RPM. You can burn them up, and you can smoke the wood and have chatter and a lot of things. The bigger the cutter, the lower the RPMs need to be. That's surface feet per minute that you need to learn about. If you don't understand that, then holler at me, and I can certainly show you that and how to calculate that. The next line is we're going to pause and let the spindle come up to speed. I put 5 seconds, so G4, P 5.0, that's just 5 seconds. Let the spindle come on and maybe warm up just a little bit before it takes off. You know, you should really turn your spindle on when you're getting set up and let it run a few minutes, warm up a little bit. But I'm not going to do that today. So then we're going to move into the feed. I put feed the Z down to the first pass. And then we're going to feed the X into the wood. Then we're going to go 38 inches like I told you in the Y direction. So we know that's not going to hit. We've already checked that. And then you can open the G code up on the ones you save from Vectric and look at the same things here and know where you're going to do. And also, when you load this in here, I'll show you in a minute, it'll also show you what's going to happen. But that's all this is, and then G1 is going to be a feed rate, so you got to put a feed rate the first time you pull the G1 up. I'll put Z minus 40 thousandths. At the feed rate of 60, so it's coming down to the cut. Remember, we're off the material here. Now we're going to feed into the material, and then we're going to move 38. I think I already told you that. Then we're going to come off of it 2 inches. We're going to drop the Z down to 80 thousandths. We're going to come back into it. In the X center line, we're going to come right back to our Y0 here. Then we're going to come back off of it. See here, X minus 2. We're going to come down, Z minus 120. And you'll see these numbers coming up on your DRO as it's running. It'll be exactly what it's saying here. And then we're going to feed it back up 38 inches, back off the material, and then we're going to park this. So I'll put this park position at 10 inches to the left of where we set our 0. Somewhere like this area, and Y 10 inches, so it'll park somewhere around in here, out of our way. See, I put in here park machine out of the way. M5 turns off the spindle, and be careful because it spins down slow. You don't be touching stuff, you can cut your fingers off. M30 ends the program, and that's all. So now all we got to do is go load this program. So we're going to load file. We'll go find that program that we just had in here. And don't know why it's giving me trouble finding it, but there it is. It's at the bottom. Okay. So we're going to open that. And you can see there it is. I really don't like how it turns this to a weird position. I think it's because some monitors are sitting the other direction or something. But down here, like I was telling you, it'll also show you the Z is only going to go to a minimum of minus 0.12, 120 thousandths. They need to fix these numbers. That drives me crazy. They should be showing 3-digit numbers here for inches. So minus 120. See, if that was 125, it would say 1.13. But anyway, that's a different story. And the maximum it's going to go is 1 inch. So remember I told you it's going to start at 1 inch. These are some things you should check before you ever run. The maximum the Y is ever going to see is 38 inches. What we talked about already. And the minimum it's going to ever see is to the 0, which is there that we've set. We've already verified it's not going to hit nothing there. And then the X, the most negative it'll ever see is 10 inches, and that's where we parked it. And you can see that represented here in the program, or on the screen here. It's going to park right out here, out of our way. And you can go over here to info, and it'll also show you an estimated time that it's going to run. The feed rate's going to be at 60 inches per minute. That's pretty slow probably. You can always slide this speed up as you're running if you want to. It's actually right here, the feed rate. You can slide that up or down if you need to while you're running. Same with the spindle, and get that better the way you want it. But anyway, that's all there is to it. So this is ready to run. I've got a switch. This may be noisy, but let's go ahead and run this. And we already feel confident that we know everywhere this thing's going to go. This may be loud. Let me move this microphone down over here. Maybe it won't be as loud for you. I don't know. And let's push the button here and let's run it. Oh, the spindle's not coming on for some reason. What did I do? I don't know what I've done, but it's not like, I just updated this the other day. There may be a setting here that it's not liking. Let's just keep pushing it until see here what it's not liking here. That's weird. Alright, let's stop that. Now that's weird, I haven't had this trouble. I may need to reboot this computer or this deal, because there's something funny going on here. It's not liking. And there's not any problem with any of that, so G0, G20, G7. Oh, I got G20 in there twice. It says I do, I don't know. Let's go, let's close that. Let's go and look at that file again. I'm sorry for this interruption here. I don't know what it's doing. I've never seen it do that before. I do have G20 in there twice. I don't think that should matter, but I don't know why I've got it in there twice. G0, G20, G17. Yeah, I updated this just the other day. I don't know if I've ran it since then. I wonder if it don't like these spaces. It used to not matter. You could put spaces in your code. Let's get rid of the spaces and see if that's going to matter. I don't think so. I have had to reboot, restart G-Center before when it does some weird stuff. So let's just let's load this file again and see if that fixes anything. Here we go. I guess it didn't like them spaces or something. you see that's feeding in real slow right there? That's a mistake. I should have put a G0 right there so it would do a rapid move right there. That's the thing with typing your own code. You have to be sure that you're not doing any typos like that, because to fix that, let me show you right quick. All you got to do to fix that is, we're not going to run this again, but I mean, just want to show you where I messed that up. Is see right here where I parked that. This was in G1. Once you call up a G1 or a G0, you don't have to call it again. And all these moves will be at that G1 feet of 60. That's 60 inches per minute. And all of these moves, when I parked that right here, I should have put G00. And that puts us back in a rapid move. And that would have worked really well. So anyway, that's the only reason it did that. But I guess the reason that errored out on us a while ago was because I had two G20s in there and it didn't like that at all for some reason. So I guess once you call, that had two G20s in there earlier, and once we fixed that, see right there, it only has, well, it has two right there, but oh, here's the time we ran it. No, I tried to run it several times. That's why this is in there so many times. Yeah, right there is that line G0, G20, G17, G90. Yeah, that's it anyway. So anyway, I hope there's something in here that can help somebody understand how your moves work and how you know where your machine's going to be going and what it's going to do, and there's no surprises. You're not writing on Facebook going, oh my word, how come my Z did this? Well, it does exactly what you tell it to do, and just like you noticed that I made some mistakes there that I had to go back and fix because it did exactly what I told it to do, and it wasn't what I wanted it to do, was it? So that's how that works. So anyway, hopefully that's helpful to you. If not, then skip it, don't watch it. But if you want to go in that video to that spot where all those G codes are described there, or if you would like for me to send that to you so you can do it, then just reach out to me in the comment here, and I'll tell me your email address or contact me on the Altmill group or any of the CNC groups. Larry Robinson is my name on all of the groups to do with this kind of work, and I do CNC machining for a living, and that's just what I do, and this is just for fun here. That's why I waste time doing things like this, because I enjoy doing it. Yeah, I could go out the table saw, cut that off, but we wouldn't have learned nothing, would we? And it's good practice to write some of your own code and edit some of your own code, and I'm not going to waste a lot of time, but you know, just for the fact of the code that I just did with the one I did on the Vectric, this is the code that it wrote, and see, it writes the same thing because I have my post processor edited to put this startup line in there, but it went to Z 2 inches, and then it did all these moves and all that. But it's the same thing. It's the same thing as you write, basically. Nothing really different. It puts some extra moves in there a lot of times you don't need, but it's still only moving where it was told to move in the program. So yeah, in this case it was going to I was going 41.5 inches. That was before I knew how long that board was exactly. I wrote that early this morning when I was in there just thinking about this video. All right, thanks hope that was helpful. Anyway, I don't want to waste too much of your Saturday, so y'all have a great weekend, and reach out to me anytime you need help. I'm happy to do it.